As I told, this is also one of the interesting solid wherein you have to draw the projections of the hexahedron. As I told in the previous class itself, these are two special case of solids. One is the tetrahedron and another one is the hexahedron. As the hexa means here it is six, hydron means faces, so it is a six-faced solid. The six-faced solid here, it is nothing but a cube. Instead of the name cube, it has been written here as the hexahedron. Hexahedron of size 30 mm is resting on one of its corners on HP, so corner condition problem. And there is a special mention here that it's one of the solid diagonal is perpendicular to VP. No other inclinations were given here. Instead, they have just mentioned that it is resting with one of its corner on HP. So corner condition problem, the first position or the initial position easily you can draw assuming the corner condition, and the next position you have to draw using this solid diagonal condition. Solid diagonal is perpendicular to VP, they are given here. Solid diagonal is perpendicular to VP. So we'll go for drawing the solution here. As I told, initial position we have to draw similar to the corner condition problem. A cube will be seen as a square in top view. So that square will be drawing now. So 30 mm is the side of the square. So 30 mm by 30 mm, as it is corner condition problem, will give the inclination as 45-degree inclination will give here. 45-degree inclination will give here. We'll place it here. So this is your cube, right? So the cube will name the different corners of the cube. So A in the bracket A1, then this point is B in the bracket B1, right? It is a cube is similar to a prism, only the difference is, so if instead of the square prism, we are having a cube here. That means all the edges are of same size. That is why it is a cube here or a hexahedron here. So these points we have marked. Then we'll go for drawing the front view. We'll take the thin line, draw the projectors upwards, XY up to XY line. We'll draw the projectors from various corners of the first top view. Then we'll draw the front view now, right? The height here, it is again the same edge, that is 30 mm height. I'll draw 30 mm here. From this corner also, I'll raise 30 mm here and 90-degree and the join like this. Then here also, I'll raise the height of 30 mm. Then the base I will draw here like this. So this is your front view of the given cube. Front view of the given cube has been drawn now. These points I can mark now. So this is the point A1 dash here, and this point is B1 dash in the bracket T1 dash, and this point is C1 dash. In the top surface, we'll have A dash here, and this corner is B dash in the bracket D dash, and this point is C dash. So this is the initial top view and initial front view, wherein the hexahedron is resting with one of its corners on HP. That corner we have taken it onto the right side here. Now we have to go for drawing the second and third position. Here no inclinations were given here, no inclinations were given, but they have mentioned that the solid diagonal is perpendicular to VP. What is the solid diagonal? The solid diagonal is the line joining the bottommost corner, say point C1, to the opposite of the top face corner. So that is called as the solid diagonal. So solid diagonal, if I identify here, the solid diagonal is the line joining this C1 dash to A dash. So this is the solid diagonal. So this solid diagonal, I have to make it perpendicular to VP. So in the third position, perpendicularity comes here. Perpendicular to VP comes here in the third position. So in the second position, what we will do is, in the front view, we will make it parallel to XY line or parallel to HP. Parallel to XY line or parallel to HP. So this solid diagonal, I have to make it parallel here, parallel to XY line. For doing that, I need one more construction here. I will draw a perpendicular line to this solid diagonal from point A1 dash. From point A1 dash, I will draw a perpendicular to C1 dash A dash from A1 dash. So I will take a line tool now. I will draw a line like this right? If I draw a line like this, I don't know whether it is perpendicular or not. I'll simply draw like this. A line, I will draw like this. Now I'll turn on the relationship toolbar here. So this is the relationship toolbar. What I will do is, I will select this line, right? I will click on this perpendicular and I'll click on this one, right? What I have to do is, I'll select this perpendicular to this one I have to make, right? So otherwise I should say select these two, I'll make them perpendicular, right? So what is not doing, so select, right? Click on perpendicular to this one, I have to click here, right? Not going on. I'll just zoom this area, you just see, right? So this one I selected, right? So I have to click here perpendicular, click this and click this. So now you can see it is perpendicular. Now if you measure this angle, right? So angle between this and this line, if you measure, you can see it is 90 degree now. So what we have done is, we have drawn a perpendicular line to A1 dash C1 dash A dash C1 dash from point A1. Extra line I will trim off. I will use the trim tool now, right? Extra here, I will trim off this line. So this is A1 dash, say this point I will call it as say M dash, right? So A1 dash M dash is perpendicular to A dash C1 dash. So in the third position, if I want to make this A1 dash C1 dash perpendicular, sorry, parallel to XY line, then what I can have to do is, I will make A1 dash M dash vertical here, the perpendicular, right? That I can do, right? For that, so we have drawn this perpendicular to A dash C1 dash from point A1 dash. This A1 dash M dash is perpendicular to A dash C1 dash. So now we'll go for drawing the second position. So what I will do is, I will select the whole thing, right? I'll select the whole thing, right? I will use the move tool, create copy on. Now I have to choose A1 dash as the reference now. I will choose A1 dash as the reference and I will keep it on XY line. Now I will go for rotating here, right? I will go for rotating as I told. Instead of making that parallel, I am making this line perpendicular, right? I will make this line perpendicularly here. So perpendicular marker, when it comes, I'll just leave here. You can see now this A dash C1 dash. This point is actually, so this point I will mark here. So this is C1 dash. Now A dash C1 dash is parallel to XY line. These points also I will mark. So this is the point B1 dash in the bracket D1 dash. And this point is A1 dash. All those points we have marked. M dash is here. A1 dash M dash is now perpendicular to XY line. So A dash C1 dash, that is the solid diagonal. Solid diagonal is made parallel to XY line now, or parallel to HP. Now we'll draw the projectors downwards. Take the line tool. Thin line you can choose, right? Draw the vertical projectors downwards. Draw the vertical projectors like this from point A1 dash, B1 dash, like that. From various points, we'll draw the vertical projectors here like this, right? C dash, like this, I will draw, right? Yes. I'll draw the vertical projector like this. So it will coincide on the same line. Here from B1 dash also, I will draw the vertical projector. It will coincide on the same line. So I will draw the horizontal line here. From the first top view, I will draw the horizontal line like this. Sorry. Okay. Extra lines I will trim off. Use the trim tool. Extra lines can be trimmed off like this, right? Extra lines I trimmed off. I will mark the various points now. Take the annotation tool or text tool, right? Project line drawn from A dash and A. So this will be the point A. Project line drawn from B dash and B. So this is the point B. Project line drawn from C dash and C. So this is the point C. Project line drawn from D dash and D. So this is the point D. Similarly, project line drawn from A1 dash and A1. Here is the point A1. Project line drawn from B1 dash and B1. So this is the point B1. Project line drawn from C1 dash and C1. Here is the point C1. Then the point D1, the point D1 comes here, right? Likewise, we have marked the point. Now we'll join the outer edges with a thick line. Take the thick line, continuous line, outer edges, all outer edges I'll join with a thick line. A to B, B to this B1. So I have to just zoom that area. Otherwise, I'm not trimmed properly. Then trim it here. Use trim tool and trim. Alright. So I'll zoom this area so that it is clear. Right. I'll take the line tool again. So B to B1 outer edge, B1 to C1 is an outer edge, C1 to D1 is an outer edge, clearly D and A back. So outer edges I joined with a thick line for now. Now we have to look at this from the top. When you look at the second front view from the top, ABCD is nearer to the observer, A1, B1, C1 is away from the observer. So ABCD will be visible. So it will be a thick line. So AB already I joined. B to C, it join with thick line. C to D, you can join with thick line. And C to C1 also, it will be a thick line. So thick lines I joined. And now this C1 to A1, that I can make it as a hidden line. I'll just trim this so that it will be clear, right? So I take the hidden line now, hidden line, dashed line, here thick line only, this A1 to this C1. This I will make it as the hidden line. Extra lines I can trim here also. These are all extra lines not required. So this line is also not required. So I trim these. So these lines I trim. That is the second position. You can see here in the second position, the solid diagonal A dash C1 dash is parallel to XY line. Now we'll go for drawing the third position. So in the third position, what we have to do is we have to make the solid diagonal perpendicular to XY line. We have to make the solid diagonal perpendicular to X. Solid diagonal is AC1. So this AC1, I have to make it vertical here. Here it is horizontal. So I will to make it vertical. So for that, what I will do is I will select the whole second top view. I will make a copy now. Alright, use move, create copy on. I will place it here like this somewhere here. Right. Now I will use rotate. Right, and I will make C1A. Here I'll rotate like this. It is now vertical. C1A is vertical. Right. C1A, I will make it as vertical like this. Right. Now I will mark the various points. Right. Here you can see here this point is, I'll delete it. I'll redraw it once again. So this is the point C1. Right. Then this point is A. Here B is there. Right. I'll just delete this. So I'll draw it once again. So this point is B. Right. And this point is B1. Right. B1. Then C1 is there. So here is D1. I'll just delete that and draw it once again. Right. This point is D1. Right. Similarly, here A is there, B is there, this C. Right. I'll just mark it once again. Right. So this point is C. And this point is D. D also I'll mark here. Here. So I'll take here. This is the point D. And this A1 and C both are coinciding here. A1 is in the middle, no? Where it is? A1 dash. Where is this A1 dash? So I not marked. Yeah, it is correct. Here in the middle. Right? So this line I will draw so that you can easily get that line. That thin line I will draw here. Alright. You can get that intersection point. That is the point A1 here. Alright. So this intersection point is A1. So here I not joined A1, B1, C1, D1 with a hidden line. But also I have to draw here in the second top view. So I have to draw that A1, B1. A1 to B1 is a hidden line, and A1 to D1 here it is a hidden line. Same thing I have to mark here, right? So A1 to B1 is a hidden line, and A1 to D1 is a hidden line that I have not marked earlier. Now I have marked it. Now we'll go for drawing the vertical projector. Take the line tool, thin line. So draw the vertical projector like this, right? You can draw from various corners. So only 3 parallel lines will be getting. So those 3 parallel lines I will draw now. From the first top view, second front view, I will draw the horizontal projectors now like this, right? From various points of the second front view, I am drawing the horizontal projector. Extra line I will trim off, use the trim tool, and extra lines can be trimmed off. Now we mark the various points. Take the text tool, projector line drawn from A and A dash. So this is the point A dash. Projector line drawn from B and B dash. Here is the point B dash. C here and C dash. So this point is C dash. Projector line drawn from D here, right? So here it is A, B, C. This is D, not D1. So this is D actually, right? So this point is D. So projector line drawn from D and D dash. So this point is D dash. Similarly, projector line drawn from A1 and A1 dash. So this is the point A1 dash. B1 and B1 dash. Here is the point B1 dash. Then C1 and C1 dash. This is again the same point C1 dash. Then D1 and D1 dash, it comes here D1 dash. Outer edges will join with a thick line. Take the thick line, right? And continuous line. So all outer edges. So this one is an outer edge. I'll join with a thick line. This is again B1 dash outer edge, B1 dash to A1 dash, A1 dash to D1 dash, D1 dash to D dash, D dash to C dash will join with a thick line. Outer edges we have joined with a thick line. Here you can see ABCD is nearer to the observer. A1, B1, C1, D1 is away from the observer. So ABCD you have to join with a thick line here, right? That is the top surface. That surface will join with a thick line. So A dash to B dash, and then A dash to D dash will join with a thick line. So this also will join with a thick line. Remaining lines will be hidden lines. So remaining are here D1 dash to C1 dash, it is a hidden line. C1 dash to B1 dash, it is hidden line, and this one hidden line it is. I have to mark it as the hidden line. These two lines so are hidden line. And this one also. So this extra line. So I'll just trim that, right? So that I can mark it properly as the hidden line. I'll take that hidden line, thick line only. Then I will draw from C1 dash to C dash as a hidden line. So this completes the solution. Extra lines you can trim off here. So this also not required. So I can trim like this. Extra lines were trimmed here, right? So this is not required. Okay. So you can see here the solid diagonal, whatever the solid diagonal we identified in the first set of views, that is C1 dash A dash. So that C1 dash A dash here, C1A is now perpendicular to XY line or perpendicular to VP. So that is the solution for this problem. So remaining is dimensioning. So we have to show the dimensions here. Take the dimension tool, whatever the height this one, whatever this length, you show it, that completes the solution. So this is the solution for the problem wherein a hexahedron is drawn with one of the corner on the HP such that the solid diagonal A dash C1 dash is perpendicular to VP. So this completes the solution. This is again one of the important problem in most of the question papers. So this particular problem will be asked, and many times it has been asked. So you have to practice well, right? You have to practice this problem well. You have the catch of the problem or the crux of the problem is finding this perpendicular line, drawing the perpendicular line A dash C1 dash to A1 dash M dash. So that is how you have to draw the perpendicular line, right? So in case of your sketchbook also how you have to draw You have to see that. But in the final examination, you need not draw this problem in the sketchbook. You will be directly drawing it on the system, right? Now we'll go for the next problem. The next problem is the cone problem here. So this is the cone problem. A cone of base diameter 40 mm and axis length 55 mm is resting on HP on point on the circumference of base such that the apex is at a height of 40 mm above HP and its top view of the axis is inclined at 60 degrees to VP. So here, in the second position, generally, as I told, axis inclination will be given, but here they are not given the axis inclination. Instead, they have mentioned that apex is at height of 40 mm. So with that, we can find out what is the inclination of the axis with HP. And third position, top view of the axis is inclined at 60 degrees to VP here. Top view of the axis, nothing but apparent inclination of the axis is directly given in the problem. Apparent inclination of the axis is given here. Apparent inclination of the axis is 60 degrees to VP. So you have to draw the projections of this cone and you have to find the inclination of the axis with HP when the base is nearer to the observer. Base should be nearer to the observer. So we'll go for drawing the solution for this problem. I will take the circle tool now, right? Continuous line, thick line, diameter is 40 mm. So at 40 mm diameter, I will choose here. So I will place this circle here. Now this circle I have to divide into 8 equal parts. I will take a thin line now, right? I will divide the circle into 8 equal parts. Horizontal and vertical diameters I have drawn, and from this point at 45 degree inclination, right? Whatever the length is here, 20 mm and 45 degree, right? And from here also 20 mm and this 135 degree, right? And this side also 20 mm and minus 45, and this side it is 20 mm and minus 135. So with this we are dividing the circle into 8 equal parts. You can see here I divide the circle into 8 equal parts. I will name all these points. So this is the point A, this is the point B, this is the point C, this point is D, this is the point E, this is F, this point is G, and this is the point H, and the apex is O, and the bottom base of the midpoint of the bottom base is O1, that is the axis. O1 is the axis. Now we'll go for drawing the front view. As it is a cone, we have to draw the front view as similar to this one. That is, we'll mark the point A here, that is A dash. Likewise, the various points will mark of the base of the given cone in front view, right? In front view, we are marking the base. Then we have to go for raising the axis height. Axis height is 55 mm, 90 degree. So we are getting the apex here. Then the apex should be joined to the base as a thick line. All these lines I will join here, right? Like this. I will continue, right? So these lines I will join like this. Now these lines I have to make it thick. So I'll go for making it thick, right? Then these generators I will draw it as thin line only. Generators of the cone I will join it as thin line only. These are all generators of the cone. So generators of the cone were made as thin line. And this line is the axial line. I will mark it as the axial line here, 0.25 mm thickness. So this is how the front view of the cone will look like. All these points I will mark now in the front view. So this is the point O dash, and here I will mark the point A dash. This point is B dash in the bracket H dash, and this point is, right, C dash in the bracket G dash, and here the point D dash in the bracket F dash, and the last one is E dash, and this point is also O1 dash. All those points we have marked. Now we have to go for drawing the second front view. In the second front view, we have to see that the axis is at a height of 40 mm from HP or 40 mm from XY line. For that, I will take the line tool. I will choose thin line only. I will take a point here. From this, I will take a height of 40 mm at an inclination of 90 degree. So this should be the axis, that is apex now. So this is the apex O dash. So with the apex O dash, we have to redraw the first front view now. For that, I'll choose the whole of this first front view. I will use the move tool, right? Move, create copy is on. The apex should be moved to this 40 mm, that is this point. Now we have to rotate. We have to rotate this such that this one will coincide with here. So we'll go for rotation now. We will use rotate. I'll select this particular generator. I'll rotate like this. It is lying on XY line. So this will be lying on XY line like this. Otherwise, the other method is you have to take this distance with 0.2 as radius. You have to cut and all those things you can do. But here in the computer, directly you can do this. Now we'll go for marking the various points. So this point is A dash. This point is B dash in the bracket H dash. This point is C dash in the bracket G dash, and this point is D dash in the bracket F dash, and this point is E dash. Here the point O1 dash is also there. Now we'll draw the vertical projectors downwards. Take thin line only, continuous line and thin line. Draw the vertical projectors downwards. You can draw from A, B, C, D, etc. You can draw the vertical projectors downwards like this. Alright. So this is what we are doing. We are drawn the vertical projector from various points of the second front view. Then we'll draw the horizontal projector from the first top view. We'll draw the horizontal projector from the first top view like this. Right? Extra lines will trim off. Use the trim tool, right? And trim off these lines. So this apex also I have to join here. So I'll join from here to here. That is point O. This also I will trim off. Yes. I'll mark the various points now. Take the line tool. Project line drawn from A and A dash. This is A. Here is the point B. This point is C. Here the point D comes. This is the point E. Here F. This point is G. And here is the point H. Extra lines you can trim off. So you can zoom this area. So these are the extra lines. I'll just trim those extra lines. So point B is here only. And point D is here only. Right? And this point E up to, so it is not required. Up to here only it is sufficient. This one also not required. So A, B, C, D, E, here F. F is up to here only. Then G is up to here only. So this is G. Like this, you can get all those points. Right? G, H like this. Right? I'll just draw the ellipse now with this all these points. We'll draw the ellipse. So I'll just zoom this area so that you can clearly see how it is drawn. So take the ellipse tool, right? Here ellipse by center point method, ellipse by center point, a 3-point method I can choose. So this is the center of the ellipse. So this is the minor axis. Sorry. So ellipse by center point method I'll choose. So center of the ellipse is this one, and this is the minor axis, and this is the major axis of the ellipse. So with this we'll draw it as a thick line. So we'll draw it with thick line. Now what I told, so you have to see whether this whole of the bottom base is visible or not. When you look from the top, the bottom base is hidden. So we have to mark all the bottom base actually hidden, but this the outer edge it will not be hidden. Only this portion will be hidden. So for that we have to split. Use a command called as split command here. Split. So select this, right? At this point you have to split here and here. You have to split it. So it is split into two. You can see here. This is one part. No, it's not split. So again I will select split, right? I will select this one. So this is the first point for splitting, and here is the second point for splitting. It is split into two now. You can see, yeah, it is split into two. So this one we have to make it as hidden line, and the outer edge now we have to join, right? For that, take a line tool here, that is thick line only you can choose. Join from this point to here as a tangent. To this, you have to join as a tangent. You can zoom this area so that you can get clearly a tangent. Tangent marker will appearing, join as a tangent. Here also same thing. From here, you have to draw as a tangent to this curve, this arc, right? Draw as a tangent. When the tangent marker appears, just click, right? Then this is how it looks like. So this is the point O, right? The point O1 will come here. This is the point O1. So the line joining O1 to O, you have to mark as an axial line. Take the axial line now, right? 0.25 mm thickness, join from this point O1 to O as an axial line. So if it is not visible, you can just trim that. So first you trim it so that you can easily draw that axial line. So axial line, then thin line, point from here to here, that to join as an axial line. Now you can see the second set of views have been drawn. In the second set, you can note that the apex is at a height of 40 mm from the base. So this height you have to measure here. So distance between, you can choose here, distance between this to this point, it is 40 mm now. And even this axis height is 50 mm, and this circle is having a diameter of 40 mm, right? So these are second set of views is completed. In the third set, you have to make the axis to appear at 60 degrees to VP. Top view of the axis is inclined at 60 degrees to VP, meaning that the axis appears to be inclined to VP by 60 degrees. So take the line tool, thin line only you can choose. So from here, draw a 60 degree line. 60 means 180 plus 60, that is 240 degree, right? So 240 degree you can take here, and this angle you can see. So this angle is 60 degree. So this is 60 degrees to VP. Now we have to rotate this second top view such that this axis is at 60 degrees to VP. So for that, you select. So all those points also I need there. So whatever those other points are there, here you can see I'm having the points here, A, B, C, D, etc. All those points also I want it, right? For that, what I can do is, one method is I can take the line tool here, right? Thin line, I can join these lines as the generator. So I can join from O to F as a generator here, right? O to H as a generator. I can join here like this, right? So then I will get all those points. Then O to B as a generator, then O to D as a generator. If you join as a generator, so these endpoints will be there. Automatically you can get those points. So I'll take this now, whole of the second top view I will take. I will make a copy, use move, create copy on. So this point O, I have to keep it on this 60 degree line. Then I have to use rotate. I will use rotate. So select O01 as the reference for rotation. It should be rotated such that it will coincide at this 60 degree. And one more thing they have given here is the base is what they are told. When the base is nearer to the observer, when you rotate like this, you can see here the base is nearer to the observer. So you have to rotate like this only. Otherwise, if the base is away from the observer, means the base should be upwards. But here the base is nearer to the observer, means you have to rotate like this only. Now we are having the various points. Those points you can project to the front view and get the final front view. Project line drawn from O here, O dash. So you will get the point O dash here. This is the point O dash. Then project line drawn from A, right? Even I can zoom this, still it's possible. Yes. Project line drawn from A here, right? And A dash, right? Somewhere here. Yes. This is the intersection point. So this is the point. Extra line I'll trim here so that I'll get the better control here. So this is the point A dash. Similarly, project line drawn from B and B dash. So here is B dash. So I will get that point. So this is B dash, right? So this is B dash. Similarly, project line drawn from C. So here is the point C, C and C dash. So C and C dash like this. Extra line I will trim off. So I'll get the point C dash. Then project line drawn from D here, right? So this is D and D dash here. I can join like this. So D dash. So this is your point D dash, right? So you got D dash. Similarly, project line drawn from E. E is here. Yes. E dash here. E dash. Then project line drawn from F here. So this is F and F dash. So this is the point F dash. Then G and G dash. Here is the point G dash. Then H and H dash. Here is the point H dash. You can mark those points, right? You can mark these points and you can join them with a smooth curve. You have to use the curve tool now. Curve tool. Here continuous line, thick line only you have to choose, and see that while drawing the curve, maintain relationship is off. Now join from here now. A, then this is B, and this point is C, this is D, and this point is E, this is F, this is G, and this is H, and this point is now E, sorry, F, H, right? This is the point. So A, B, C, D, G, H, this is back to A, right? So this is how I'm drawing this curve, right? So then I have to join this to the apex O. Take the line tool, thick line, continuous line. So the point O should be joined to this as a tangent. Here also this point should be joined to this as tangent. You have to join as a tangent. Alright, so this is how we have joined as a tangent. So these points you can mark now. So this is the point O dash, and here the point A dash, here is the point B dash, here is the point C dash, this is the point D dash, this point is E dash, and this is the point F dash, this is the point G dash, and lastly this is the point H dash. So axis also I have to mark now. Take the line tool from point O1. So this is the point O1. Draw a vertical line. So this is your point O1. O1 to O you have to join as an axial line. O1 to O join as an axial line. So this is axial line. So this point you can mark here as the point O1 dash. So this is the point O1 dash. So this completes the solution. So wherein the cone of base diameter 40 mm and axis length 50 mm is resting on HP on a point on the circumference, such that apex is 40 mm above HP and the top view of the axis is inclined at 60 degrees to VP. And the axis, you have to determine the inclination of the axis with HP. What is the inclination of the axis with HP? You have to find out angle between this to this, that is the inclination of the axis with HP. Axis inclination of the axis with HP, you can note here. So this value is 23 degree. So that value you can write now. Take the text tool. Here you can mention the angle here. So I can write here alpha. Alpha is equal to 23 degree. Degree symbol I have to insert. Go to character map, right? Select the degree symbol. Select, copy, close. Go to this text box. At the end, you paste here. Control V means pasting, right? Other extra characters can be deleted here, right? Press the delete key. So you will have the degree symbol. So alpha is equal to 23. We are getting that value, right? 23. We can get that. That is the inclination of the axis with XY line or with HP, right? So this you have to find out. So this completes the solution for the problem. If you are having any doubts, you can ask me now. Any doubts, Pratyusha?
No, sir.